Dear students, now theory of first chapter has been finished and we will start numerical. First numerical is a polythene piece rubbed with wool is found to have a negative charge of 3.2 into 10 to the power minus 9 coulomb. It means total charge is 3.2 into 10 to the power minus 9 coulomb. Estimate number 1, number of electron transferred from which to which, means polythene to wool or wool to polythene. Second, how much mass transfer from one to another. And we know that Q is equal to number of electrons into charge on electron, and we have to determine the number of electrons. It means N equal to Q upon E. Total charge is 3.2 into 10 to the power minus 9 coulomb upon electronic charge is 1.6 into 10 to the power minus 19 coulomb, and it becomes 2 into 10 to the power 10. This is number of electrons, and as it is negative, it means electrons are transferred from wool to polythene. And how much mass transferred? Total number of mass should be equal to number of electrons into mass of one electron. Number of electron transferred 2 into 10 to the power 10, and mass of one electron 9.1 into 10 to the power minus 31 kilogram to 18.2 into 10 to the power 10 minus 31 means minus 21 kilogram. This much mass is transferred from one to another body. Now, second problem depends upon Coulomb's law. Electrostatic force on a small sphere of charge 0.4 microcoulomb. We can consider Q1 0.4 microcoulomb, or we can write 0.4 into 10 to the power minus 6 coulomb. Due to another small sphere of charge minus 0.8, Q2 equal to minus 0.8 microcoulomb or minus 0.8 10 to the power minus 6 coulomb. In air is force is 0.2 Newton, and we have to determine the separation between the two spheres, and we know that as Coulomb's law, F is 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and R square should be 1 upon 4 pi epsilon naught Q1 Q2 upon F, and R square equal to 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9. Q1 is 0.4 into 10 to the power minus 6. Q2 is 0.8 into 10 to the power minus 6 upon force is 0.2, and 0.2, 0.4 it becomes 2, and 9 into 2 18, it becomes 10 to the power 9, 10 to the power minus 12, 16, 144 into 10 to the power minus 4 meter square, and we have to determine R. R is square root of 144 into 10 to the power minus 4. Square root of 144 is 12, and minus 4 10 to the power minus 2 meter, or we can say 12 centimeter. Separation between two spherical sphere is 12 centimeter. Third problem, 4-point charges QA, QB, QC, QD are located at corners of square ABCD. This is a square A, B, C, D, and this charge QA 4 microcoulomb here, and QB minus 7 microcoulomb, QC 4 microcoulomb, QD minus 7 microcoulomb are located at corners of square ABCD of side 10 centimeter. Side of square is 10 centimeter. What is the force on a charge 1 microcoulomb placed at center? Here is a charge of 1 microcoulomb. And we know that this is a positive charge and this is negative charge. It means force due to this charge, it should be attractive and it should be in this direction. We can consider it FB. Direction of FB is in this direction. And similarly, this is positive charge and this is negative charge, and direction of force due to this charge is again in D direction. So it should be FD. It means FB and FD both are opposite to each other, and as both charges are same in magnitude, it means FB equal and opposite to FD. And now this is positive charge and this is positive charge. It means they repel to each other, and if they repel to each other, so F force due to 4 microcoulomb, it should be in this direction. It means FA. Direction of FA is in the direction, and direction, and again it is positive and it is positive, so it should be repulsive. Direction of due to this charge in this direction, it means FC and FA is again equal and opposite, and here total force should be FA plus FB plus FC plus FD. FA is cancelled out by FC, FB is cancelled out by FD. It means total force on center is always equal to 0. Next problem of this chapter again depend upon Coulomb's law. Two electric charges Q and 2Q are at a distance A. These are two charges 2Q and Q, and separation between these two charges is small a. Apart from each other in air, a third charge capital Q is to be placed along the same line in such a way that the net force acting at Q and also at 2Q is 0. Suppose this is the position of third charge, and we consider that it is situated from small q is at x, and it becomes A minus x. 2Q is 0. Net force on this charge due to Q and 2Q is 0. It means we can consider force between small q and capital Q is suppose in this direction F1, and force between capital Q and 2Q is in this direction repulsive, and we can consider F2. And net force is 0. It means F1 equal to F2. F1 means 1 upon 4 pi epsilon naught small q capital Q upon x square. This is force between small q and capital Q, equal to 1 upon 4 pi epsilon naught 2Q upon Q A minus x square. This is force between capital Q and 2Q. 1 upon 4 pi epsilon naught cancel out, Q cancel out. 1 upon x square equal to 2 upon A minus x whole square. 2x square equal to A minus x square, and x under root 2 equal to A minus x, and x plus, and we can also say plus minus x plus minus x under root 2 equal to A. X plus minus x under root 2 equal to A, and x 1 plus under root 2 equal to A if we consider plus, and if we consider minus then it becomes x 1 minus under root 2 equal to A, and x equal to A upon 1 plus under root 2 or 1 minus under root 2. This is distance from small q. Next problem depend upon torque acted on dipole. An electric field, an electric dipole with dipole moment means P equal to 2 into 10 to the power minus 8 coulomb meter, is aligned at 30 degree, theta is 30 degree, which with the direction of a uniform electric field. Electric field is 3 into 10 to the power 3 Newton per coulomb, and we know that torque is Pe sin theta. P is 2 into 10 to the power minus 8. E is 3 into 10 to the power 3 sin 30 degree, and it becomes 2 into 3 into minus 8 or 3 minus 5 sin 30 is 1 by 2, and it becomes 3 into 10 to the power minus 5, and unit of torque is Newton meter. Next problem is find magnitude and direction of an electric field will balance an alpha particle. Suppose this is a alpha particle, and the alpha particle having positive charge equal to twice of electron, and it is balanced by any force. We know that gravitational force is always working in downward direction, and it will be balanced by upward force. It means electric direction of electric field should be in upward direction. This should be the direction of electric field, and electric force on this alpha particle should be in this direction. This is electric force, and this electric force will be balanced by the weight of alpha particle. It means electric force equal to weight of alpha particle, and this should be the balancing condition. Fe equal to Q into electric field, that should be equal to mg, and we have to determine electric field. Mg upon Q. M mass of alpha particle is equal to 4 times of mass of proton, and mass and charge. Charge is 1.6 into 10 to the power minus 19 coulomb, and charge on alpha particle is twice of charge on proton, twice E. And M becomes 4 into 1.67 into 10 to the power minus 27, G 9.8, and Q twice of proton, 1.6 into 10 to the power minus 19 coulomb, and the answer becomes 2 into 10 to the power minus 7 Newton per coulomb. This is the value of electric field, and direction of electric field is opposite to the weight.